is an electronic circuit that places the positive peak or negative peak of a signal at a desired level. Okay, so now this particular clamper circuit, it also has the other names, which is called as DC restorer, or you can also call it as a level shifter. Okay, it is called as a DC restorer or a level shifter. Now the question is, why is it called a DC restorer and why is it called a level shifter? The circuit of clamper is called a level shifter based on this phenomenon, because it is trying to shift the peaks of the signals. Okay, it is trying to shift the peaks of the signals to a particular position. So that is why we call it as a level shifter. Then why is it called as DC restorer? In the process of shifting the peaks, positive peak or negative peak, what the circuit is doing is it is trying to insert, okay, it is trying to insert the DC component. It is trying to insert a DC component, and it is because of this circuit is called as DC restorer. Okay, so that means in order to shift the peaks of the signal to a different level, the clamping circuit, it introduces or it inserts a DC component. Okay, and inserting the DC component is making the positive peak or negative peak to have a shift. Okay, so that's why we call it as a level shifter, and since it is introducing a DC component, we call it as a DC restorer. Now the question is, in which cases do we find this DC component to be inserted, okay, or to be included? That is normally in television receivers. Okay, normally in television receivers, what happens is we go for what is called as capacitive coupling. We go for what is called as capacitive coupling. So in this, when we introduce this capacitive coupling, what is coupling? Coupling is nothing but connecting one to the other. So for example, in terms of our electronic circuits, coupling means if you have two different circuits like this, circuit 1 and circuit 2, if you want to connect these two, we go for what is called as the coupling mechanism, where the output of one circuit, we take it as input to the next circuit. Okay, we take the output of one circuit and connect it as input to the next circuit. This is what we call as capacitive coupling. In the process of capacitive coupling, what happens is the DC component gets deleted. Okay, the DC component gets deleted. So in such cases where the DC component is required and at the same time capacitive coupling should be used, in such cases we use what are called as DC restorer circuits. Okay, so this is what we have as a clamping circuit. Now, what are the different components that I find in a clamping circuit? So in case of clipper, we said that we have a resistor, we have a diode, we have a reference voltage, okay, for biasing or to take the clipping to a different level. So these are the components we discussed in clippers. Now, what are the different components that we find in clamper? So as I said, this is one of the applications of the diode. So obviously diode's presence is required, isn't it? Then second component that we see here is the presence of a resistor. And third one is important thing here is the capacitor. Okay, so these three components mainly form a clamping circuit: diode, a resistance, and a capacitor. If required, we can go for the reference voltage also. Okay, if required, we can go for the reference voltage also. Okay, so these are the different components that I see in a clamping circuit. Okay, now what are the different types of clamping circuits we have? So that depends upon here based on our definition. So what is that we said? It is shifting the positive peak or the negative peak, right? For example, if I take an input like this, let us say I am taking a square wave. So what does the clamper circuit do? The clamper circuit will give you an output like this. So what happened here? The positive peak has been shifted to the zero axis, isn't it? And at the same time, the negative peak is shifted by the same proportion. The negative peak is shifted by the same proportion downward. Okay, so this is what you see, the positive peak shifted to the reference axis, that is x-axis. Similarly, For example, if you have an input like this, now if you have an output like this, so what is that I see now? The negative peak has been shifted. So that means based on these output waveforms, how many types of clamping circuits we observe?
2.
2. Can you name them? What are they?
Positive clamping circuit.
First one we have it as a positive clamper, and second one we have it as a
Negative
clamper. So it is about these two types of clamping circuits, and their operation, input output waveforms and applications is all what we have to discuss. Okay, so this is a introduction of the clamping circuits. Now let us talk about the two types of clampers in details with the help of the waveforms. Okay, so first one, let us take positive clamper. So how do you define a positive clamper? A positive clamper is nothing but an electronic circuit which shifts the positive peak of the input signal to the reference level or to the desired position or desired level. Okay, it shifts the positive peak of the signal to a desired level. That desired level here usually can be the 0 level or to certain reference voltage. Okay, so that means by shifting this, what is the positive peak undergoing? It is undergoing a shift downward. Okay, the circuit is pushing the signal positive peak downwards. Okay, so this is what we call as the positive clamper. Now, how do we have the circuit for this? Okay, so the first component that you come across is a capacitor in series arm, followed by a resistance, and then the diode. Both are in parallel to the resistance, to the capacitor, like this. Okay, so this is where you measure the output voltage V0, and this is where you apply the input voltage Vin. So some textbooks use Vi, some textbooks use Vin, but finally both are same, they represent the input voltage. Fine, so this is resistance R, capacitor C, diode D. Naming of the components is very, very important. Okay, so this is how you have the clamping circuit. So I said the components are diode, resistance, capacitance, and if required, you can place the reference voltage also in series to the diode here in this shunt arm. Okay, so now what type of input I have to apply here? In case of clipping circuits, the input we have given are sinusoidal signals, right? We have given sine wave as a signal. But in order to understand simply and very easily the operation of a clamper, we are going to use here a square wave. We are going to use here in clamping circuits a square wave. So you can use either sine wave also as input. But after understanding the operation, I will tell you how sine wave will be affected for this clamping circuit when given as input. Okay. So because why I have taken square wave is, as you see in square wave, you have only two reference voltages. You have either the maximum voltage or you have as the zero voltage, right? Or negative voltage here. Whereas if you take the sine wave, each and every instant of time, the waveform amplitude is going to change. But in case of square wave, it is not so. So that is the only reason why we take the square wave for understanding the clamping operation as the input. Is that clear? So that means now I'm trying to go do my analysis with the input taking as the square wave. And axis remains the same, time period here. And usually we go with voltage. And since I'm showing input voltage, I can name this as Vi. And remember, when you are showing both input and output on a single graph, okay, don't show this as Vin/V0. Show it as voltage axis. And the waveforms you try to point them as input and output. Okay. So now with this as the input and going to the circuit, what is the output voltage V0? This is what we have to understand. So before proceeding further to understand what is output voltage V0, there are certain things that you have to recollect about the capacitor because those are very, very important here. What is that? First thing that you need to remember about the capacitor are, what is that? Capacitor, basically it is a storage device, right? This is the first thing that we should always remember. Capacitor is a storage device. Okay. Then when capacitor is fed with any input voltage. Okay, when capacitor is fed with any input voltage, what does it do? Based on this principle of storage, capacitor immediately, what does it do? It
Charges.
charges to what? Charges to maximum voltage of input. So let us say if your input is 5 volts. So when that is, for example, this is 0, this is 5. For our understanding, I am writing here. So when this positive half cycle goes as input to this circuit, what happens? The capacitor here immediately charges to this 5 volts. That is what I mean by capacitor charges to maximum voltage of input. Okay. And another important thing is capacitor. Okay. It doesn't allow any sudden changes in what? Yes.
Input, ma'am.
Any sudden changes in its voltage. So now earlier I said that capacitor has been charged to the maximum voltage, right? What is the maximum voltage? Example, I have said it is 5. Now let us say negative half cycle is going as input to the circuit. What happens? Capacitor which was charged to 5 volts now is receiving a drop in voltage. That too it is a negative voltage. Yes or no? So whenever a capacitor is experiencing sudden changes in voltage, okay, immediately what does it do is it starts discharging, and whenever it is discharging, it always take the help of a resistance. So the resistance that is present in the circuit is nothing but this R. So the 5 volts which was charged here, when the input turns to the negative half cycle, capacitor starts discharging through RL. So these are the important things that you need to remember about the capacitor. Okay, what is the first one? Capacitor is basically a storage device. Okay, first thing. Second thing you have is it whenever the capacitor is available in a circuit and we are trying to give an input voltage, the capacitor immediately charges to the maximum voltage of input. And third thing is it doesn't allow any sudden changes in voltage, isn't it? And if there are any sudden changes in voltage, what happens? The capacitor starts discharging through R. So with this basic information in mind, we need to proceed to understand the circuit of a clamper. Okay. So how is that? And in all these things, we are also assuming that our diode is an ideal diode. I am not taking the diode to be a practical diode. Okay. So I clearly explained why we generally go with the ideal diode. So since there is no V gamma concept, it is very easy for us to understand the operation. Okay. So we are assuming that the diode is an ideal diode. Now how to analyze this particular circuit for this applied input? Okay. Analysis procedure is the same. Since your input has 2 half cycles, we will start our analysis with the first one, that is the positive half cycle as input. So for positive half cycle of input, what is the output going to be? Okay. So for that, you should first determine what is the state of the diode, what happens to capacitor C. So can anyone say first one, what happens to capacitor C for positive half cycle as input?
The capacitor get charges, ma'am.
Okay. So let us assume that the maximum voltage here is V. Okay, this maximum voltage is V here. So what happens now? For the positive half cycle of input, capacitor charges to V, isn't it? Because V is the maximum voltage. Then what about the state of the diode? So positive voltage, right? So the diode is receiving plus here, minus here. So what is the state of the diode?
On.
Is it on?
Off, madam.
Diode is reverse biased because it is encountering first a cathode, and cathode is receiving a positive voltage. So the diode will be reverse biased. So it is in off state, isn't it? It is in off state. Now, what is the equivalent circuit here when the diode is in off state? Capacitor, resistance, and you don't find anything here. So this is nothing but V naught. And this is where you find VI. Now, what is this output voltage equal to here? Normally, we said output voltage is voltage across R, right? But for me to know voltage across R, I should know current passing through R. Then only I can say V naught is equal to current into resistance. But here I don't have any information about the current. Okay, only except that I find what are the different voltage levels that are existing. So V naught is voltage across this R. I know what is input voltage because its maximum voltage is V, and the capacitor is also charged to the maximum voltage V. Okay, so that means capacitor also has some voltage across it. Then these are the polarities of voltage across the capacitor. So now how do I find out this output voltage when I have the information of voltages in a circuit like this? What electrical principle we should apply? Anyone? In a circuit, if you have different voltages like this, and if you want to find one unknown voltage, what law or what principle you have to use?
Ohm's law, ma'am. I into.
What is it?
Ohm's law.
What is that?
Ohm's law, ma'am. Okay.
It is nothing but KVL, Kirchhoff's voltage law. Kirchhoff's voltage law. KVL is what you apply. And this is the loop. Now you apply the KVL equation. Find out the KVL equation here. So it starts here with minus. So I can write it as minus VI plus, sorry, it is next immediate voltage that you see is capacitor here. Okay, so it is encountering negative first. So minus VC. Then it is voltage here across R, which is nothing but V naught. So I write it as plus V naught equal to 0. So KVL says that sum of all the voltages present in a circuit is equal to 0. Sum of all the series voltages present in the circuit is equal to 0. Now from this find it what is V naught. So what is V naught from this? It is simply VI plus VC. Now what is the maximum voltage of V in? We said it is V, right? So this is what we called as V. And what is the capacitor charged to? Capacitor also is getting charged to the maximum value of input V. So finally, what is V naught equal to? It is equal to 2V. Okay. So for the positive half cycle, you see that the output voltage is nothing but equal to twice that of the maximum voltage of the input. So now if I plot this as a waveform, let me draw the input with a broken line like this. Fine. So 0 V. This is voltage axis, this is time axis because I'm showing both input and output on the same path. Now, what is that we said for positive half cycle, this portion, output is equal to 2V. That means double the times of this voltage. So what is that I can show here? Let us say somewhere is this double time voltage. So this is where I find maximum, and this extends up to positive half cycle like this. So this is nothing but 2V here. Now, let us analyze this for negative half cycle. So can anyone say what happens for negative half cycle? Quickly. So for negative half cycle, what is happening? The circuit here, now it is receiving a negative voltage. It is receiving a negative voltage with a maximum voltage of minus V. This is minus V. So whether it is the maximum voltage of minus V or any value less than 0, capacitor which was charged to the maximum voltage V now is experiencing a sudden change in voltage. Now we said that capacitor doesn't allow sudden change in voltage. So when it is experiencing a sudden change, what happens? Discharging of capacitor takes place. Okay. So what is that you write here? For negative half cycle as input, we see that capacitor starts discharging. And also, what is the state of diode D?
On state.
It is on state because it is receiving negative here, positive here now. So your diode is forward biased. So it is in on state. So what is the equivalent circuit at this instant? So capacitance followed by resistance. But here the diode is shorted because it is in on state. Now, whenever we have anything in parallel to the short circuit, the resultant one also will be replaced by a short circuit like this. So now your capacitor is not able to discharge because there is no resistive path, isn't it? So finally, what is the capacitor voltage here equal to? So now if it is a negative half cycle, you have minus plus, right? That is minus plus. Now what is the polarities here is negative half cycle. So this is minus, this is plus here. Because I'm talking this for a negative half cycle. Now this is shorted because of which this capacitor resistance also becomes shorted. So now what is the output voltage V naught? What is output voltage V naught here?
0, ma'am.
Yes, 0 because there it is a short circuit. Positive and negative has been shorted, got connected. So output voltage V naught is equal to 0 volts. So for the negative half cycle, you find that output voltage equal to 0 volts. Now what do you guess is this capacitor voltage here? So you apply KVL like this. So capacitor voltage is VI minus VC plus V naught, but plus V naught is 0, right? So this is 0. So finally you are left out with capacitor voltage is equal to the input voltage Vi. This is only just for information we are evaluating, that's all. Nowhere in the output waveform we are going to show. Output waveform we categorize only for these two. So now what is the final output waveform that you see? It is this you need to plot on the waveform. So it is for negative half cycle, output voltage is 0. This is 0, right? So this is how you have the waveform. And now if the waveform is continuous, so what will be the next output? It goes to 2V and then again it drops to 0. So finally, the one with the broken line is nothing but your input waveform, and the one with the solid line here, it is the output waveform. Clear? So this is how we have the input output waveforms of a positive clamper. Okay, and next class we will discuss about the